sometimes you can't find rational roots, and so you have to look at the graph and you have to approximate the real roots. But we can do it a little more specifically than just looking at the picture and going, ooh, that looks to be about 3, but it's a little more, and so then you start approximating and it gets a little weird. So we can look at this numerically. What we want to make is t-chart or table of values, whatever you want to call it, x values and y values. And looking at this graph, this is the graph of x cubed minus 2x squared minus 4x plus 2. And we can see here that here we've got about -2, and there's a 0 between that and -1. There's a 0 somewhere between 1 and 0, and there's a 0 just about where 3 is. So I'm going to check all the numbers between -2 and 3. Actually, let's check it to 4. And so if I do that, I'm going to make a table of values where x is -2, -1, 0, 1, 2, 3, and 4. Now when I say we're looking for zeros, I'm looking for the points where the graph crosses the x-axis. So I'm looking for these values. So I want to know what x values are those 3 points. So what I do is I take -2, and we could do this a couple of different ways. We can either use synthetic division, or we could just plug -2 in for x and see what value we get out for y. Because we've just done synthetic division, I'm going to use synthetic division. We get 1x cubed, -2x squared, -4x's, and 2. Bring down the 1. 1 times -2 is -2, which gives us +4. -4, which gives us then +8, which is, there's the +4. And -8 gives us a remainder of -6, which means at -2, y is -6. And we keep doing this over and over and over again. If you have a calculator, like a graphing calculator, and you can just change the values in a function, this is easier. Or you just keep plugging numbers in. And when you do that, you get -1 is 3, 0 is 2, 1 is -3, 2 is -6, 3 is -1, and 4 is 18. Now, because it says to the nearest half unit, I've got to compare some of these values. Now, when y changes from negative to positive, or positive to negative, it means I've crossed the x-axis, because down below the x-axis are negative y's, above the x-axis are positive y's. So if I switch from positive to negative, I must have crossed this x-axis line at some point. So I'm going to look at only those pairs of values. So here, somewhere between -2 and -1 I've switched, somewhere between 0 and 1 I've switched, and somewhere between 3 and 4 I've switched. Since we're checking to the half unit, let's check what -1.5 yields, x and y. Let's check what 0.5, because that's halfway between 0 and 1, what that gives us for x and y. And let's also check halfway between 3 and 4, 3.5. What I'm now looking for is numbers that are closest to 0. Because it means that I've gotten closer to the x-axis than I have with either of these two numbers. So if I plug in -1.5, again, you could either do synthetic division or you could just plug the number in. But when you do that, you get an answer of 0.125. So looking at this, -2 yielded -6. -1.5, we get to 0.125. -1 gives us 3. 0.125 is the closest number to 0 out of those 3 numbers. So that means our first 0 is -1.5. X equals -1.5. Our second, let's try plugging in 0.5. If we do that, we get -0.375. 0.375, or -0.375 is closer to 0 than either 2 or -3. So my second 0 is 0.5. And finally, we just plug in 3.5, or synthetically substitute 3.5, and we get 6.375. Now looking at these numbers, -1 is closer than either 6.375 or 18. So since -1 is the closest to 0, 3 is our last root. Since we're only approximating to the nearest half unit, they are your 3 answers. Now, in this one, what we're going to do is we're going to do the same thing. We've got x to the fourth minus x cubed plus x squared minus 3x plus 1. Now, you're looking at x to the fourth and you're saying, well, there should be 4 different solutions. And there are. 2 of them are real roots. The 2 real roots are here, or 2 real zeros are here and here. There are also 2 imaginary roots, which is why we don't cross the x-axis 4 times. We're only crossing it twice. So we're now only looking for 2 solutions, which makes our job a little easier. And looking at where those solutions are, they seem to be somewhere between 0 and, I'm going to guess 3, it could be 2, so let's check all of them. So we're going to check x and y in a t-table, 0, 1, 2, and 3. Now if you don't have a graph, this becomes a pain in the butt, because then you've got to check every single number on the number line, and that could be time consuming. So what we do is we either use synthetic substitution or we plug the number in and we get the y values out. When I plug in 0, I get 1, then I got -1, 2 is 7, and 3 I got 55. So this hash mark here is obviously 2 because, well, A, if you counted, it would be the second one, and B, I'm not switching from negative to positive between 2 and 3. But I am switching from positive to negative between 0 and 1, and between 1 and 2. So we're going to check both of them. Between 0 and 1 halfway is 0.5, and if we plug in 0.5, we get negative 0.3125. And for 1.5, we get 0.4375. So we get this for our x and y values. X and y, x and y. So let's check each group of 3. If we check each group of 3, here, 1, -1, -0.3125, this number here is closest to 0, so my first root is x equals 0.5. And we look at -1, 7, and 0.4375. Well, obviously this is closest to 0, so our second root is 1.5. They're the half-unit approximations. If you were asked for tenths, which would be tedious, but if you were asked for tenths, you'd go 0.1, 0.2, 0.3, 0.4, 0.5, and look again for where you're switching over, and then you look at which number is closest to 0.